Hello, my dear students. Welcome to the live session on YouTube. Today's concept would be electrical measurements. I hope you all are doing it fascinatingly fine. How you all are doing? Hope my voice is clearly audible. Rahul, welcome to the session. Rahul, hello, how are you? In fact, I welcome each and everyone for this live session on electrical measurements, my dear students. Can somebody confirm to me like whether you can listen to my voice properly? Yes, okay. Prasanna, hi. Good afternoon. Uday, good afternoon. Welcome. Aishwarya, hi. How are you? Ananya, good afternoon. Uday Kumar, good afternoon. Very good afternoon. So each one of you can hear me properly, right? My voice is clearly audible. Yes. Good afternoon, Kirtana. Very good afternoon, Sridevi. Good afternoon, Megha. Good afternoon, Ananya. Yes, thank you. Thank you for your confirmation on the voice and video clarity. You just set it above 340p. Then the clarity will be much better for you all. So this is my second session, consecutive session on current electricity. Yes, Deepa, good afternoon. Very good afternoon, Deepa. Janvi, good afternoon. Megha, all of you are heartily welcome to my this particular current session on electrical measurements. In fact, this YouTube platform is such an energy filled platform that this keeps on providing us a lot of energy, and this energy we will take it further to go ahead and focus on the sessions more and more beautifully. So I hope these sessions are going to help you in a long run. With this particular note, let me just move ahead to my discussion. So in order to like go ahead and provide you those who have joined to this session recently, for them I would like to give an introduction regarding me. My name is Uttam Kumar Umarji. In fact, I have taught JEE Advanced, JEE Main Physics for 19 odd years at Delhi, Kota, Bangalore, and all across India. And I have taught closely to 10,000 plus students till date. And currently, I'm working as a NEET JEE KCET faculty, senior faculty at Prarthana PU College, and this is my third month actually on Unacademy platform. And in fact, this platform has given me a lot of love and affection and a lot of enthusiasm via students like you all. Okay, so now let's move ahead with our discussion for the day. But prior to that, let me just offer you like what Unacademy can provide you. Unacademy offers you some of the beneficial plans. Let's quickly have a look at that. We have Unacademy Plus subscription. Yes, Mahadevi. Yes, Srushti at Srushti. Right. Okay. Good afternoon. Good afternoon. So here, Unacademy Plus subscription has been one of the lucrative beneficial plans for you as in comparison to any sort of online education package pan India. And this is one of the highly economic plan that can be offered to you as students, because you should spend less and learn more. So that is where I as well as the team Unacademy is aiming at, and this is the cost that you will be paying per month. So you just think about it. We have a 6-month plan which will cost about 1688 rupee per month, and we have 1 month plan 2250. This is only for the new subscribers. Okay, this is a trial price. And what all you will get, you will be getting a comprehensive batch which is already live here. Just like me, there are many enthusiastic teachers who are willing to teach you, and they will provide you, including me, we all will provide you a lot of support and a lot of motivation in learning new concepts in a much better way. Okay, so what you will be offered here, you will be offered a premium content at highly affordable price. Structured live courses will be there, then quizzes at regular intervals for self analysis, then batches for complete preparation would be there. Okay, and test series like for DPPs, full length mocks, everything will be provided to you under one cost. So think about it. And this YouTube classes, YouTube live classes are also a part of it. And in order to avail a straightforward 10% discount, you can make use of UTTAMLIVE as your referral code. This is my referral code for YouTube live classes. Okay, thank you for your patient listening to these all things, and I suggest you keep this in your mind and think wisely. Let's proceed towards the problems that I'm looking forward to solve today. I hope you all are very much energetic. And Vijay Lakshmi, hi. We have Narsing. Yes, very good, Narsing. Welcome. Aditi, good afternoon. Mahadevi, good afternoon. Then we have Vijay Lakshmi. So all of you are highly energy filled students who are motivating me a lot many of ways, and you all are good learners as well. Soumya, very good afternoon. Chaitra, very good afternoon. Now let's progress to the session. Shall we begin with the sessions, my dear students? Yes, hi. Karnakar Rao, hi. How are you? Good afternoon, good afternoon, very good afternoon. Now let's progress with the class. Shall we go ahead with the class? Yes. Okay. I hope the voice is not echoing. Voice is proper now. Yes. Okay. Thank you, Prasanna. Thank you, Janvi. Fine. Thank you. Thank you. Let's progress with the class now. Now, this is the first question that will be shooted to you directly. Now, the length of a wire of a potentiometer, okay, is 100 centimeter, and the EMF of its standard cell is E volt. It is employed to measure the EMF of a battery whose internal resistance is 0.5 ohm. If the balance point is obtained at L is equal to 30 centimeter from the positive end, the EMF of the battery is. Okay, so now this question, uh, it is one of the highly simplified questions. So let's go ahead and crack this question quickly. Now, here it is said that if we consider E1 is equal to E, okay, and L1 is given as 100 centimeter, that is the balancing length for you, my dear students. Then, and when the battery of unknown EMF E2, I am taking E2 as E dash here, as you can notice, is used. In that situation, balancing length is given as 30 centimeter for us, right? So hence we should go ahead and apply principle of potentiometer here. So hence we'll say E by E dash is equal to 100 by 30, right? So E by E dash is 100 by 30. How can I say that? Because E is directly proportional to balancing length. So due to that reason, I can write E dash is equal to E multiplied by 30 by 100. That happens to be option C, my dear students. Yes. So hence we can comfortably go ahead and mark option C as our right choice here. Okay, so this was the question that we are supposed to solve, and we have cracked it. I hope this solution is clear to you all. Now let's progress to our next problem quickly. Now, second question. In a potentiometer experiment, the balancing with a cell is at a length of 240 centimeter. On shunting the cell with a resistance of 2 ohm, the balancing length becomes 120 centimeter. The internal resistance of the cell is. Now, here, my dear students, this problem is based on internal resistance by using potentiometer process. So hence what we can write the given things as L1 is given to us as 240 centimeter, L2 is given to us as 120 centimeter, and then resistance is 2 ohm here, and we should find what? Small r, that is internal resistance. Okay, now here internal resistance of a cell is given by what? R is equal to L1 minus L2 divided by L2 multiplied by the resistance that is connected, right? So that connected resistance is 2 ohm here. So hence if we just supply all these values properly, then 240 minus 120 is 120, 120 divided by 120 is 1 multiplied by 2, that will provide me the internal resistance as 2 ohm, right? So hence we can say that the internal resistance is obviously 2 ohm here. That is option D that has been provided to us in the option list, right? So now let's progress with our next question quickly. I hope this methodology is clear to you all. Any particular doubt you have? Right. Now let's progress with our next question, my dear students. A meter bridge is set up as shown here. Okay, as you can notice, meter bridge setup has been shown here. To determine an unknown resistance X using standard 10 ohm resistor, the galvanometer shows null point when tapping key is at 52 centimeter mark. The end corrections, now let me just mark this off, this is 52 centimeter mark. The end corrections are 1 centimeter and 2 centimeter respectively for the ends A and B. The determined value of X is, so we should find the value of this unknown resistance X, which is connected on the left hand part of the meter bridge. Okay, so that is the question, and prior to answering this question, let us go ahead and understand what is end correction, right? So let's ask that question quickly. What is end correction? Now if we just try to answer what is end correction, now I have brought back this meter bridge diagram for our reference. So here the shift in the balance point due to the winding of the wire at ends A and B. Now as you can notice here, at point A and at point B, when I stretch a wire and connect, will I not be winding it at these connections? Will I not be turning them into a winding, because I should fasten them, no? So that fastening that I do, that process, okay, that will provide me some error, because I'll be stretching the wire and then winding it at both the knobs, right? So I hope you are able to visualizing this. You are able to visualize this. Are you? Are you able to visualize this? Yes. Okay. So due to that, we will have what? Shift in the balance point. And this shift in the balance point is nothing but end correction, my dear students. So hence, here we never consider the length of the wire that is wound to the knobs at A and B. At these ends, some length of the wire has been wound, no? So obviously that length of the wire that is wound, that we are neglecting. So that will provide me an error, and that is end correction, my dear students. And this is the error that we should consider and solve this problem. Okay, so as per the problem given, we should go ahead and tackle it in this way. I hope I'm clear on end correction now. Is it feasible? Is it understandable? Yes. Okay, now let's proceed to the question. So we'll just go ahead with that. Okay, now as you can notice, a meter bridge is set up as shown, and they are saying the galvanometer shows null point at 52 centimeter mark. The end corrections are 1 centimeter and 2 centimeter respectively for ends A and ends B. So that means at end A 1 centimeter worth of wire is wound, at end B 2 centimeter worth of wire is wound. So that much length we should consider back. Okay, so hence we can say here R is 10 ohm and unknown resistance is given as X. That is what we are supposed to find, my dear students. Then end correction on left is how much? Delta L1 is given as 1 centimeter, and end correction on right, that is delta L2, that is 2 centimeter, right? So accordingly here L1 will be equal to what? L1 will be L plus delta L1. Okay, and L1 is actually L is given as how much here? 52, right? 52 centimeter from end A we will consider. Hence to that I will add this delta L1. So accordingly I'll get this as 52 plus 1, that will be 53 centimeter. Okay. Next, L2. In order to calculate L2, now if length from end A is L, then from end B will it not be 100 minus L, because length of a meter bridge is 100 centimeter. So hence I am considering 100 minus L as the balancing length from point B. Okay, then to that I'll be adding delta L2 here. So obviously here I'll get what? 100 minus 52 plus delta L2. So 100 minus 52 is 48 here, plus 52 plus delta L2 is what? 2. So that will give me L2 as 50 centimeter with the end correction. I have solved this now. Okay. Now next step is what? We'll utilize these L1 and L2 values and go ahead and crack this problem. Okay. So in order to do that, I'll be utilizing this meter bridge principle. According to meter bridge principle, X by L1 should be equal to R by L2. Very simple, right? So hence I'll key in all the values that are given to us. So hence X will be equal to what? L1 multiplied by R by L2. So L1 is 53 here. Okay. And R is 10 divided by L2 is 50. So if you just work this out, 530 by 50, that works out to be 10.6 ohm. 10.6 ohm happens to be option B here, my dear students. Was this problem a jellifying problem? Was this not like eating a Kit Kat, right? But you have eaten a Kit Kat, but you have not taken a break now. Instead of that, you are enjoying the Kit Kat and you are eating it, and this is the endless Kit Kat. You keep on eating it. So that is the end correction, my dear students. I hope this end correction concept is clear to everyone. Any particular query, any particular question, kindly post it. Hi BS Didimani. Yes, okay. So I hope my uh, explanation is highly clear. Everyone have understood these concepts properly. Yes, Prasanna, any doubt? No. Okay. So anybody are having any doubt? Anybody? I would like to see like how we are progressing with the class. Okay, fine, fine. Thank you. Thank you, Sidhu. Thank you. Thank you, Uday. Sri Devi. Thank you very much. Okay. So this is the motivation that I want from your end as well as from my end. You should get highly motivated through YouTube live classes. Okay. I hope this is okay Fine, very good. Now let's progress with our next question. Fourth question. Now, during an experiment with a meter bridge, the galvanometer shows a null point when the jockey is pressed at 40 centimeter using a standard resistance of 90 ohm as shown in the figure. Okay. The least count of the scale used in the meter bridge is 1 millimeter. The unknown resistance is the beautiful problem. With the least count, we should go ahead and solve this problem. Previous one was end correction, and this one is obviously based on least count. Now let's go ahead and crack this problem quickly, my dear students. I hope you all are jacked up and fastened your seatbelt. Now let's progress. Now, for our reference, I'm just keeping the question here with small font. I think this is visible to everyone. Now let's progress. Now from meter bridge theory, what is the theory that we know? R by S is equal to L by 100 minus L, and here they say that S is 90 ohm, L is 40 centimeter, right? So accordingly R can be calculated. R is given as unknown, so 90 multiplied by 40 divided by 100 minus 40, that should give me 90 multiplied by 40 by 60. 40 by 60 is nothing but 60 ohm here, right? So 60 ohm is the answer for a value for R. Now after that, now let us consider 100 minus L as L dash. 100 minus L as L dash, that is the second balancing length. So from left hand side balancing length is L, then from right hand side what should be the balancing length? 100 minus L, so that I am taking it as L dash here. So accordingly I can write R by S is equal to L by L dash. Simple, right? Okay, so thus R will become equal to 90 multiplied by L by L dash. Okay, now let us go ahead and take the difference equation. So absolute relative error method I'll apply here. So applying relative error method, here in place of R I'll get what? Delta R divided by R. Okay, and then L, delta L by L I'll get, right? Then L dash will be delta L by L dash by delta L dash by L dash, and 90 being a number that is omitted out of the error equation, right? So this is what we have done here. Fine. Now let me just change the color here so that visibility will be good for you all. Fine. Okay. So accordingly, next step I can write here delta R becomes equal to what? Now out of delta R by R I have simply cross multiplied, and what I have done here is delta L by L I have kept it as it is, but in place of L dash can I not write it as delta L by 100 minus L? Do you agree or not? Do you agree or not? L dash, delta L dash, can it not be written as delta L? Okay, and L dash as how much? 100 minus L. So that is what I have done here. Okay, so I hope it is clear. Yes, so here this is what? This is L dash, my dear students. So this is L dash. Okay, I have written for L dash here. Fine. So now next step, I'll substitute simply all those values. Now delta L is given as 0.1, is it not? Yes. Then as you can notice, 0.1 by 40 plus 0.1 by 60. Yes. So thus I'll multiply it by 60. Yes, that should give me how much? 0.25 ohm, right? So accordingly I can write R is equal to 60 plus or minus 0.25 ohm. So here who went ahead and answered quickly? Prasanna answered. In fact, Prasanna, very good. Janvi, you have understood this, right? Okay, so obviously here this is the answer that we are expecting, my dear students. So this is option B here, my dear students. I hope it is clear. Fine, fabulously clear. Now let's progress to our next question. Question number 5. In a given figure, the potentiometer wire AB has a resistance of 5 ohm and length of 10 meter. The balancing length AM of for the length of 0.4 volt is. Okay, so this is a straightforward question which we can quickly go ahead and answer it like AM. I'll take it as a L. AM I'm taking it as small l. Okay, then can I not write EMF E is equal to, okay, that is E by capital E by small e is equal to what? So I can mention it in this way also, EMF of the cell divided by R plus RH plus small r. Okay, R plus RH is what? This balancing length, this wire's resistance, that is RH is rheostat resistance, R is resistance of this potentiometer wire, and small r is internal resistance multiplied by capital R by L, that is resistance per unit length multiplied by length AM. So accordingly I can write here zero point 0.4 is equal to 5 by 5 plus 45 plus 0, that is internal resistance is given as 0 here, so multiplied by 5 by 10 multiplied by L, so accordingly I'll get L is equal to 8 meter. So bingo, that is the answer that we were expecting, my dear students. L is 8 meter. Okay, so hence which option we can pick here? Which option we can pick, my dear students? L is 8 meter, so obviously this is option D, is it not? Yes. So now let's progress to our next question quickly, because we are left with another 2 minutes maximum. 2 minutes, 2 minutes, 2 minutes. 2 minutes are left, my dear students. A potentiometer consists of a wire of length 4 meter and resistance of 10 ohm. It is connected to cell of EMF 2 volt. The potential difference per unit length of the wire will be. Okay, so this is a straightforward question. They have asked us to calculate potential gradient, right? So hence we can quickly solve this as potential difference per unit length. I'll take it as V by L. Okay, then accordingly 2 by 4, that is 0.5 volt per meter. That's all. Simple, is it not? So 0.5 volt per meter happens to be which option here? It happens to be 0.5 is option A here, right? So option A is our right choice, my dear students. Okay, so quickly I'll just progress to seventh question. Seventh question, the maximum current that can be measured by a galvanometer of resistance 40 ohm is 10 milliampere. It is converted into a voltmeter that can be read up to 50 volt. The resistance to be connected in series with the galvanometer is. Okay, so here maximum current that can be measured by galvanometer of resistance 40 ohm. So galvanometer resistance is given as 40 ohm, current is 10 milliampere, it is converted into voltmeter that can read 50 volt. Hence we should find out the resistance that should be connected with the galvanometer to convert it into voltmeter. So thus I can very easily use this particular formula, Ig is equal to V by I minus G. Okay, where G is galvanometer resistance. Okay, so hence I can substitute all those values. 50 is the voltmeter reading that I am desiring to have. 50 by 10 multiplied by 10 raised to minus 3 minus 40. Okay, so hence we'll get the answer as 4960 ohm. So this is the resistance that I should connect to the galvanometer in series in order to convert the galvanometer into voltmeter. So this is question number 7, my dear students. Okay, and for always remember, for every good thing there is an end. So I'm saying that the time is up, my dear students. Okay, so I'll see you back in my next session with pretty more problems on electrical measurements, remaining part. Okay, then rest of the problems, and but in my next session I'll be covering few interesting problems on moving charges and magnetism. So that will be our goal. Okay, and I hope today's session was highly energy filled for you. Okay, you all found it highly interesting, so kindly key in your feedback, like my videos. Okay, share it to many people so that your teachers lectures can reach to many students who are desiring. Okay, never ever forget to use my code when you are joining newly to Unacademy. Obviously the code is UTTAMLIVE. Okay, so this is for YouTube live sessions, that is the code. Okay, so with this note, my dear students, I'm closing my today's uh, discussion. Okay, so I hope you all are highly energized with this. Okay, so let me just wind up today's session quickly. Thank you one and all. I'll see you back in my next session. Thank you. See you. Bye.